In the previous episode, one forgot to mention that those fundamental classes belong inside a com.javamaster.basics package to keep the project organized. We'll correct that in the final code, but from now on all OOP code lives in com.javamaster.oop. Let's start with encapsulation demo, whose job is to show how bundling data and methods together and hiding internal state with private fields creates trustworthy objects. The inner class BankAccount demonstrates this perfectly. Its owner, account number, balance, and transaction count are all private, so nothing outside the class can tamper with them directly. Account.balance equals 99,999 would be a compile error. The constructor validates the initial balance, throwing a legal argument exception if it's negative, and marks owner and account number as final so they never change after creation. Getters provide read-only access, and notice getAccountNumber returns a masked version showing only the last 4 digits. Which is exactly the kind of control you lose if you ever make fields public. Mutation is only possible through deposit and withdraw, both armed with precondition checks. A deposit must be positive, a withdrawal must be positive and not exceed the balance, each throwing a specific exception: IllegalArgumentException for invalid input, IllegalStateException when the operation conflicts with the current state. This guarantees the account never enters an illegal state, and transaction count increments automatically, so the object enforces its own invariance. The same principle appears in the person class, where setters trim the name and reject blank input or ages outside 0 to 150, and the constructor calls those setters so validation is applied from birth. When the run method eventually executes, it will create an account, perform some transactions, print the masked number, and then test a person object including a deliberate invalid age that we catch and log, all thanks to encapsulation. Now for inheritance demo, also living in com.javamaster.oop, which illustrates inheritance by constructing a vehicle hierarchy. The superclass vehicle marks its field's brand, model, year, and fuel level as protected so that subclasses can access them directly while keeping them hidden from unrelated code, and it provides refuel and describe methods that all descendants inherit. Car extends vehicle and its constructor must start with super, brand, model, year. It introduces a drive method that updates fuel level based on distance and overrides describe, with at override, calling super.describe, to extend rather than replace the parent's output. Motorcycle also extends vehicle, adding a type field and a wheelie behavior, while ElectricCar takes it a step further with multi-level inheritance by extending car, so it inherits from both vehicle and car. Its constructor forces 4 doors and automatic transmission via super, before recording battery capacity and range, and it overrides refuel, to represent charging instead of pumping fuel, demonstrating how a subclass can swap out a parent's method entirely. The run method creates instances of all 3, exercises their methods, and uses instanceof checks to confirm that an electric car is indeed a car, a vehicle, and an object, then shows Java 16 pattern matching. Where if v instanceof ElectricCar EC binds the variable EC without a manual cast. Today we examined encapsulation using BankAccount and person, seeing how private fields, validated mutators, and masked getters enforce invariance, and we explored inheritance through the vehicle hierarchy, learning how extends, super, protected, and at override enable code reuse and specialization. In episode 4 we'll complete the OOP package by tackling polymorphism, abstract classes, and interfaces, the remaining pillars that make all these mechanisms work together.